project of PSIM based solar panel inverter using the PSIM software. PSIM is basically in which we have just designed the input side is the photovoltaic solar photovoltaic inverter system using the PSIM software, in which the input voltage is 130 volt and thus the output is stable connected 320 V DC volt. Okay, so the thing is that first of all I just write the abstract introduction. Basically this is a DC-DC converter. Okay, this is called DC-DC boost converter. So in the PV system, this is a system overview which having the 6 solar PV modules, inverter, bridge, DC-DC boost converter, filter circuit, and the control circuit for duty cycle and gate signal generation. After that, I have just added its PV array, which is 6 solar panels, and they are operated at the irradiance condition 1000 watt per meter square, temperature at 25 degrees Celsius. Boost converter is that we have used MOSFET and the series inductor and the capacitors, output capacitor as well. This capacitor used as the stability of voltage. Okay, after that, this is the filtering and load and the control system and the final PWM using the PI controller. PI controller used for the stability of the system. Okay, so this is the overview of the system. Okay, these are 6 panels. These are the capacitor, converter, bridge circuit, and after that bridge circuit, after that it provided the output results at the output voltage. So these are the output results. Let me also show you. Yes, these are the input and output voltage of inverter circuit. Okay, and let me just, this is the power graph of output power and conclusion regarding. Let me just show you the PSIM circuit files. Okay, these are the PSIM file in which you must need to open this solar panel with converter circuit. Let me just open it and then I will show you the results of the updated software. Okay, got it. So this is the panel circuit, complete panel circuit, and the volt capacitor for filtering, and these are the MOSFET used for boost converter basically. Okay, these are the PWM technique used for duty cycle, gate duty controller and everything. Okay, let me just run this circuit first. For example, we just run here. Okay, so we need to just see input output circuit, V out, V1, okay, V in and V out. Okay, let me just yes, power as well, add. Okay, see, these are the output graph. V1 is basically red, power is this one is power. V input is basically blue line, V output is basically this yellow line. Okay, so these are the output, input and output circuit output voltages. And if you want to also change, add and delete the curves, you must need to click here. For example, we want to see the gate controller and remove all, add this, see. Okay, okay, and this one is basically when we just see this, this is the basically duty cycle, and let me just show you here. Yeah, this one. See, these are the duty gate cycle. Okay, duty gate cycle output curves. So this is a final output results based on the output voltage. Okay, so I think it is